Hello friends, I welcome you in lecture number 28 on graph theory. In this lecture we will discuss one question on isomorphic graphs which was asked in GTU Summer 2021 exam. We have discussed about definition of isomorphic graphs in previous lecture which is lecture number 27 on graph theory. So if you have not seen that lecture, you must watch that lecture first. In that lecture we have explained the definition of isomorphic graphs, and here also you have to first write the definition of isomorphic graphs, and you have to check whether the graphs given are isomorphic or not. So if you recall, in lecture number 27 we have discussed that if we want to check whether two graphs are isomorphic or not, we have to first check certain properties of graphs which are common in both the graphs if they are isomorphic. So we check all those properties one by one. First we check that whether the number of vertices are same in both the graphs. So for simplicity we denote this graph by capital G and this graph by capital H. And in graph G we can see that there are 1, 2, 3, 4, 5, 6, 7 and 8 vertices, and in graph H also you can see there are V1 to V8, that is 8 vertices. That means number of vertices are same in both the graphs. Now what is the number of edges in both the graphs? So in graph G we can say that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 edges. There are 10 edges in graph G. And in graph H also we check, this is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So there are 10 edges in graph H also. Now we check about degrees of vertices. So first we find out degrees of each vertex in graph G. Here we can see that we can see two edges which are meeting or ending at vertex U1, therefore degree of U1 is 2. Similarly there are two edges incident with U2, therefore degree of U2 is also 2. For U3 we have 3 edges ending or meeting at U3, therefore degree of U3 is 3. Similarly degree of U4 is also 3. For U5 also we have degree equal to 3, and same thing for U6, and U7 has second degree, U8 has second degree. And now we check for vertices of H. Here we have two edges meeting at V1. Similarly at V2 we have 1, 2 and 3 edges. For V3 we have 2 edges. For V4 we have 1, 2 and 3 edges. V5 is also having degree 3. For V6 degree is 2. For V7 degree is 2. And for V8 degree is 3. Now we can count the number of vertices with degree 2 in G. So here we have 1, 2, 3, 4. There are 4 vertices having degree 2 in G. And what about graph H? So here also 1, 2, 3 and 4. So here also we have 4 vertices of degree 2. Similarly the number of vertices with degree 3 are also 4 in G, and in H also we can see there are 4 vertices of degree 3. So that criteria is also checked for degrees of vertices in both the graphs. Now we can check for cycles, or we can see that if we consider this vertex U1, suppose we consider this vertex U1, then degree of U1 is 2, and U1 is adjacent with u4 and u2, and degree of u4 is 3 and degree of u2 is 2. That means in graph G, vertex u1 is of degree 2 and it is adjacent with two vertices. Here they are u2 and u4, such that degree of u2 is 2 and degree of u4 is 3. So if I want to construct a mapping or function, I have to construct image of u1 in such a way that u1 is adjacent with image of u1 is adjacent with two vertices and they are of degree 2 and 3. Now because degree of u1 is 2, we can consider image of u1 as vertex of degree 2 from graph H. So vertices of degree 2 are v1, then v6, or first we write in sequence v1, then v3 is also of degree 2, v6 is also of degree 2 and v7 is also of degree 2. So either we can allot v1, v3, v6 or v7 to vertex u1 because all these vertices v1, v3, v6 and v7 are of degree 2. Now another care we have to take care is that here u1 is adjacent with u2 and u4 and degree of u2 is 2 and degree of u4 is 3. So we have to find out that vertex among all these vertices which is adjacent with two vertices having degree 2 and 3. So now we check that these vertices are adjacent with which vertices and what are their degrees. So from graph H we can see that v1 is adjacent with v4 and v2 and both are of degree 3. What about v3? v3 is adjacent with v4 and v2 and both are of degree 3. Similarly, v6 is adjacent with v5 which is of degree 3 and v8 it is also of degree 3 and v7 is adjacent with v5 and v8 which are both of degree 3. So if I want to define an isomorphism, then for image of u1 I must have to consider vertex of degree 2 from graph H, and because in graph G u1 is adjacent with vertices of degree 2 and 3, I must have image of u1 adjacent with vertices of degree 2 and 3. But here we can see that all the vertices of degree 2 in H are adjacent with two vertices which are having degree 3. So no isomorphism is possible for these two graphs. Therefore we can say that these two graphs are not isomorphic. So that we can write here. Here I have written systematically that in graph G degree of u1 is 2 and u1 is adjacent with u2 and u4. Degree of u2 is 2 and degree of u4 is 3. Now because degree of u1 is 2, u1 must correspond to v1, v3, v6 or v7 which we discussed here. u1 must correspond to v1, v3, v6 or v7 in graph H because these are the vertices of degree 2 in H. But as we have seen that each of these four vertices in H is adjacent to another vertex of degree 3 in H. They are not adjacent to any vertex of degree 2 in H, which is not true for u1 in G because u1 is adjacent to vertices of degree 2 and 3 in G and all these vertices are adjacent to vertices of degree 3. Therefore, we can say that G and H are not isomorphic. Another criteria is we can check for cycles also. We can check whether there exist simple cycles in both the graphs, then number of cycles must be same. For example, in graph G, we can see that if I go along this path, U5 to U6, then U6 to U8, U8 to U7 and U7 to U5, then I obtain one cycle of length 4, or I obtain 4 cycle. You can see this is the cycle of length 4 starting at U5 and ending at U5. Similarly, if you observe this cycle, if we start with U4 and if we go along this path, U4 to U3, U3 to U6, U6 to U5 and then U5 to U4, then this is another cycle of length 4. And you can see third cycle of length 4, which is this square starting with U4, then U3 to U2, U2 to U1 and U1 to U4. So in graph G we have 3 cycles of length 4. Now if G and H are isomorphic, we must have 3 cycles of length 4 in graph H also, and we assume that all these cycles are simple, that is all the edges in the cycle are distinct. So here in graph G we have 3 simple cycles of length 4, and if G and H are isomorphic, I must have 3 simple cycles of length 4 in graph H also. So we can check in graph H, this is one obvious simple cycle of length 4, so we have obtained one simple cycle of length 4. Similarly, if we go along this square, big square, then it is another simple cycle of length 4. But there is no other simple cycle of length 4 except these two in graph H. By observing carefully graph H, I find that there are only 2 simple cycles of length 4 in graph H, and in graph G there are 3 simple cycles of length 4, and therefore G and H are not isomorphic. So you can write using this criteria of cycles also. In graph G there are 3 simple cycles of length 4, but in graph H there are 2 simple cycles of length 4, therefore given graphs are not isomorphic. Or you can write whatever we discussed before discussing these simple cycles. Okay, you can write in this way also. So there are several ways of showing that given graph is not isomorphic. So in this way you can check whether graphs are isomorphic or not. And I stop here. If you have any questions, you can ask in comment section, and we will continue with this type of GTU exam questions on isomorphic graphs in upcoming lectures. Thanks for watching.